Hello guys. So in this tutorial we're gonna talk about VAT animation. VAT stands for Vertex Animation Texture, and it's the way to store animation frame data inside the matrix in the texture space. Then we extract this data in our shader and provide this to the world position offset. So it helps us to get rid of the skeletal mesh animation and play this animation runtime on the instant static mesh. That lowers CPU cost because everything is calculated completely on the GPU side. This thing is useful for crowds and RTS games. Before we start, I need to tell a few more things. So, for those of you who want to understand how this VAT thing works from scratch, I'm gonna leave a link to this article. It was published 3 years ago, but it's still valid. And it explains everything better than I do. So, you may see it has a lot of information. It also has some code which can be used I guess in Blender and Unity. But for us, those who use Unreal Engine, we have the native plugin called Animation Texture. It's still experimental, but they update it from version to version, and it becomes better. It was published once Unreal Engine 5.0 came out with the city sample or the matrix. They used it for crowds. And you may also see that it's completely free. Speaking about the price, here on the marketplace, I guess you may find only one plugin which works with the VAT, and as you may see, it costs way too much. On the other hand, you have a native plugin and my tutorial, and as the output, you'll have the utility to bake the VAT texture and logic to run this VAT animation in your game. We have almost everything that they mentioned here in their description. For those of you who don't want to waste their money, especially if you solo or the indie developer, you may check out my Patreon. I'm gonna leave the sample project there with all the data. In significant less cost. It's gonna be $15, but not only for one sample, but for a bunch of stuff that I have there. So the link is gonna be also under this video. Some of you might be familiar with the Animation Texture helpers. It's editor utility widget. You may find it on the GitHub. It's completely free. It helps to work with the Animation Texture plugin, because out of the box the plugin provides only functions and material layers, but due to being experimental, it doesn't have any documentation. You may also come across this guy, Trash Praxis, who explains how this utility widget works. There is one but. If you take a look at this Animation Texture helpers, it was updated 9 months ago. Since then, we have 5.3, and if you try to use this widget, it simply won't compile. You may see that I have my sample project running on the 5.3. I do have the same version of this utility widget. Now I try to compile and I get those errors. And one of the reasons why it happened is that Animation Texture data structure that used to be exposed to the blueprints in 5.1, we don't have it anymore. Other thing is that let's see those animations. They are edgy. They don't have transitions and they don't blend at all. They don't look like that we got them from the skeletal mesh animations. And that's what I have. These guys on the right are skeletal meshes. These are instant static meshes with the what animation. Let's compare them. So we start with the same animation. The first comes the transition on the left from one state to another on the guys with the what animations. Let's compare those animations. Now we're gonna change the states and you will see how the blend works. Just like butter. If animations don't match, sometimes it might look ugly, like this, but if you provide the proper state machine or the odds of those animations, you will resolve this issue. So, the first thing that you need to do is to enable the Animate Texture plugin. So go to your plugins and just type in Animate Texture and select the proper checkbox. Then you should restart your editor and we can start. Now you have two options. The first one is to download the previous version of this editor utility widget and make changes that I'm gonna explain during this tutorial on your site, or to create the new one from scratch. For this, in the content browser, press right mouse button, select Editor Utilities and then Editor Utility Widget. We can go with the None here. Next, you should open it and provide the following hierarchy. So, the parent is the vertical box, and we should populate it with the following 5 Editor Utility buttons. Each stands for a specific action. Create static mesh from selected skeletal mesh, create data asset, create what texture, update data asset, and bake what texture. Make sure that those buttons are selected as variables, because if you select one and you don't have this checkbox selected, here at the bottom you see that you don't have any events. But once this button is variable, you have events, so you can click, press, release, and so on. The last element is details view, and there are a few things to tell about this one. The first is that if you don't have any variables declared inside your widget, this panel will look empty, so don't be afraid. So here I have those variables: SKM, SM, data asset, and so on. Other thing is you need to provide categories to show. So the first one is animations to bake, the second one is asset. So asset, animation to bake. And the last thing is that here at slot category, as the vertical box slot, the size should be set to fill. The previous version of this widget had auto, so if you compile and run this widget, if you try to populate it with as many animations as you like, you may see that you don't have ability to scroll. That's how the vertical box works. So select fill, compile and rerun the widget. Now you may see everything works fine. Now we need to create some variables, some functions, and provide logic for everything. So start with the variables. We need to have one for skeletal mesh, one for static mesh, one for the Animate Texture data asset, one texture 2D for the bone position, one for the bone rotation, one for bone weight, and a simple string for the asset directory. The last one is animation sequence, but the type should be array. Also make sure that those variables correspond to the proper category. So category here, assets and animations to bake, should match the one that we declared previously in our details view here. This one and this one. So check them one more time. This, and so on. Now we need to have 5 functions. Init skeletal mesh, create data asset, create what, update data asset, and bake what. You may see that none of them have inputs or outputs. So as I said previously, each button stands for each specific action. So you also need to call on click event for each of your button. So make SM, make DA, make what, select the one event that you like, and provide our newly created function properly for each of them. So make SM init skm, make DA create data asset, make what create what, and so on. Once you've done this, as you have variables, we need to update our details view. For this, we need to call preconstruct event, and for details view, also make sure that this one is variable. Here, we need to call function called setObject. So simply drag a wire from it and look for setObject. This new object is self, our widget. We start with the init skm. So we need the reference for our skeletal mesh, and we need to get valid from it. You can drag it, right mouse button, and convert to validated get. So if it's valid, we need to update asset directory. From our skm, we need to call getObjectPath string and then split. Split should be at the path. And we provide path path as the asset directory. If it's not valid, we use getSelectedAssets. It's the editor utility library function, which helps us to get the list of assets. So it's the drop-down menu. We filter it by class, and the class should be skeletal mesh. We check if array is not empty, then we can proceed. We get the first entrance because we can only get one element, and we set it as the skeletal mesh reference variable. Next function is create data asset. You may also see that I have this bunch of nodes used several times in different places. So probably you should copy it. That's it. I also have the local variable temp package path. So it just makes my graph looks cleaner, the way I like it. So you may skip this one. We check if the string is not empty. So then we use this bunch of nodes and provide path path as the asset directory. If it's not, we store this as the temporal path path. We also call getAssetsTool, and we create asset from it. So basically this one creates the anim2texture data asset. This type of data. For this, we need to select asset class as the anim2texture data asset from this drop-down menu. This one. Package path provide to the package path. Asset name provide with the following operation. So the file path, and we format it with the following rule. So DA underscore, so it's going to be our prefix, and in the brackets the name that we're going to use. The name is our file path. So once you create this asset, it will have the following name. So if I have my skeletal mesh called skm dummy, it will create the data asset with the prefix da underscore and the name of this asset. Then we use cast to anim to texture data asset and store the reference so I can use it in other functions. Also from data asset I use set maximum height and width and the following values. So by default they are 8K by 8K. The function that we're gonna use later actually checks if it can create the texture lower than this resolution, it will use it. Next function is create what. Here we need to have sequence of 3 because we need to have 3 different textures. The flow is similar to our previous function. So we create asset. Now asset class is texture2D. This one. We need to provide the proper asset name. Everything is the same, but and here comes the part which was broken in previous version of the editor utility widget. The one that used data structure name for it. So texture name is simple string, so you can make it on your own. Just use your brain and that's it. So each tag here comes with its own name, bone position, bone rotation, and bone weight. Next we cast the newly created asset to the texture2D. From it we extract and set compressor settings like this, and 3 of them should have the same settings. It's HDR, RGBA 16F with no sRGB. The reason is kinda simple. For this texture we also need to store normals there, and our asset should be stored as the reference so we can use it later in our other functions. Next function, update data asset. So we get the array of our animations and check if it's not empty. If it's true, we need to clear the animation sequences from our data asset, because each time we update it, the list of objects should be new but not be updated at the end of it. Or if the indexes are wrong, so it's gonna be filled inside it and maybe in the beginning and the end, so we don't need to mess with this one. After this, we iterate over our animation array and use the index and animation to update the animation sequence from our data asset. So for this, simply use insert. By default, node looks like this. So as we need to update 2 values, not every of them, we simply use split struct pin on the blue dot, like this. And we don't need to use any updates for the start and end frame or use the custom range, because we're gonna change them inside our logic later in the blueprint. Once it's complete, we need to update soft object references in our data asset for the skeletal mesh, for static mesh. We need to set the vertex animation type to be bone animation, not the vertex animation. So it set mode, like this. And the same for our soft object references for the bone, position, rotation, and weight textures. And the last function, bake what. So from data asset, you drag a wire and call animation to texture. And that's the function that's gonna bake our what textures. Next, we need to update the material on our static mesh. So the values that we get from our data asset, because once it's baked, it's gonna update the range for each animation, index and other data. So not to make it with our hands, we simply need to iterate for the static materials from our static mesh. You may see that this for each loop looks a little bit different. So for each loop, we get array element of the type, and as this one is the structure, press right mouse button and use split structure pin. Next, we need to cast to the material instance constant, and using data asset update material instance with the layer parameter. And that's it. Now, one graph, the one thing which is left is this part. So, once we need skeletal mesh, we need to call another function. It also comes with the Animation Texture library, and it's called convert skeletal mesh to static mesh. Honestly, a lot of things here can be done manually, but using this utility widget is much easier. So, for instance, you can create it's inside the miscellaneous, I guess, data asset, Animation Texture data asset, like this. Open this up, populated everything by your hand, but it's kind of dull. So, new string format for our package name. From skeletal mesh, get object path, everything the same. We make the new format. So, the prefix for our object path, and next the name for our asset. Use lot 0, because we don't need to have a lot of them, and store it as the static mesh. Once you've done everything correct, you can press compile and then run utility widget. Now let's populate the data and see what happens. So, add feature and content, third person, let's go. We have our utility widget on our screen. Here we select the queen, and it's going to be the first one. Now we press create static mesh from selected. Let's wait. If everything is okay, you may see that now we have newly created static mesh. We can navigate to its location and open it. So, as you may see, it has two UV channels. The main one, and the second one for the light map. For some reason, after 5.1, after digging inside the C++ code, I found that if the static mesh that is going to be used for baking what textures has the checkbox generate light map UVs, the code simply won't run. To prevent this, you need to find this checkbox up here and deselect it. Now, if you take a look, we have only one UV channel. So, here we have material instances, but our main material doesn't know anything about what. So let's navigate to the parent and add some logic here. I'm gonna use the shader that I used for my dummy. Just copy paste some stuff. So basically it's LORP between several values. Like this. So what it does, it takes the default normal map and we blend it with the one that we get from our material attribute layer, which is called bone animation, and it comes with the Animate Texture plugin. The same goes with our roll position offset. And why I do lerp here, because this scalar attribute, in case I'm gonna use this material not only for my, what animation stuff, but for my other characters. So 0 means I'm gonna use with no differences, no changes, and 1 I'm gonna use it only with the what characters, something like this. Or you may create the completely new material and assign it to your mesh. Also, you need to select material attribute layer, and here under the default layers, select the bone animation material layer. If you don't have the flag called show plugin content, this material layer won't show up. So for this, we need to call out our content browser. I'm gonna expand it a little bit because you have my face up here. And here under the settings, select show plugin content. Once you have this one selected, all the plugin content will be available to you. So we press apply. Now, if you select this material instance, here under the layer parameters, you may see that we have the background, which is our assigned material layer. You may see that I have one called mode, because it's the one that I created for my purpose, for the purpose of the blending and transition stuff. And as you can see, nothing here is changed. So let's see what happens next. We have our static mesh. Now let's create data asset. We create it, we can navigate it, we open it, and we see here everything is by default. Next one, let's create what textures. We create them, but they are actually empty. So as you may see, there is nothing here. Now let's add some animations that we're gonna bake. It's gonna be idle for our queen. Next one gonna be walk for our queen. Not male, but female. And run. If you press update data asset and check our data asset, you may see the references are changed. So in force power of 2, it's a good practice to have all the textures as the power of 2. Max height, max width. As you see from the tooltip, the smaller size will be used if the data fits. So it's okay. Change 8 bits to 16, so your animation won't be laggy and edgy. Modes and our textures are set as they should. And here, animations. I lost them. Yep. Here they are. They are set in the proper order that we told them here in our widget. Idle, walk, run. Like this. You may also see that our static mesh is going to use UV channel 1 for this wet magic. So in case you have several UV channels, I'm not talking about the light map because it's going to be destroyed. Simply select the one which is going to be the last one. And as far as I remember, this plugin works with the 4 UV channels. So we have everything up here. Now, let's press bake what and see what happens. So, As you may see, our references are updated and our textures are baked. I'm gonna change the model in both of my preview blueprints and see how the skeletal and the watt animation look compared to each other. So guys, on the left, they are the watt preview stuff. So, and on the right, the skeletal preview stuff. So those are two different blueprint actors, and the one which is for the skeletal mesh actually uses skeletal mesh. It's not fraud, and the function that I call each time simply changes the animation sequence. As for the watt animation, you may see that I have instant static mesh component. Here in the construction script, I populate it as the instance. And on tick event, we have the function that's going to set the custom data value for our current, previous, and alpha. So that's the blend magic. So that's the watt animation. So they both are at the same start position. First comes the animation of our watt stuff. And back to 0. So compared to the skeletal mesh, blend, back to idle. Few more things to tell you. So once we baked our watt textures, a lot of stuff were changed. It's the data asset, the static mesh reference, our materials. So if you take a look at the data asset right now, you may see that we have the read-only values for our num frames, num bones, such attributes as the bone weight and bone row per frame, the values for our size bound box and the minimum bound box, and animation start and end frames. The values that were empty the moment ago now are updated up here in the material instance. This and this. And that's the result of using this piece of code. So it doesn't contain any redundant logic that it used to. We're gonna talk about the transition between two different animations. As you remember, I told you earlier that I slightly changed the native material layer bone animation. So by default it looks like this, and honestly it has a lot of redundant information, and because everything is calculated here, I don't have control to perform the blend or transition. So I simply duplicated the layer and stored it at my place. That's how it looks, and that's all. So the idea is to sample the texture twice, but with the different frame. So we have the current frame, which is calculated during the gameplay. We need to provide the previous frame, which is stored once the state machine changed the animation from one to another. And alpha here is the simple timeline, which changed the value from 0 to 1. So here we have the lerp, which triggers the animation blend. Simple as is. So the current frame is the per instance custom data index 0, and it goes to the B input of the lerp, both for the normal and position. And opposite of this is the previous frame, which goes to the A input. So I do have the blueprint actor, which is derived from an actor class. You may see that I have the hierarchical instant static mesh component, and here I only need to provide the exact amount of the custom data floats that I have in my material. So here, instances, advanced, num custom data floats. So it's 3 for the current frame, previous frame, and the alpha. In the construction script, so as you may see, I have variable, which is the anim to texture data asset, and it's exposed to the world outliner like this. So I can change it just for the debug purposes. I extract the static mesh from it and update the model. Then, using this component, I simply call set scalar parameter values on material. So don't need to have the proper material, it's just gonna be updating on every of them. And the attribute is called use layers. If you remember, we should place 1 so the layer blend will happen. This part you can skip because it's just to populate the different number of entities. You just need to use add instance on our HISM and provide the location. I'm not gonna tell you how to make the RTS game right now, or how to make the proper state machine. It's just for you to see how this whole thing works. So we also need to store 3 essential variables. Those are current frames, previous frame, transition alpha. So each of them should be float. And we need to provide the following logic. So the calculate current frame, which is run on the tick, it's basically the copy of the material function that is used on the shader graph, but here we can control it better. So we need to get the real time in seconds. So once the game is launched, it's the equivalent of time in the shader graph. 30 here is for the frame rate of your animation, and 1 for the speed of animation. Make sure that all of your animations have the same frame rate up here. So if it's different from 30, and let's say it has some redundant keys, if you try to bake this with the wet baker, it simply won't fit in a texture. So if it's 30 frames, every animation should be 30 frames. Next, from data asset, we extract the animations and use get a copy. Here we're gonna provide the cycle counter. It's the sort of debug index, which is gonna change the state from one animation to another. As this one is the data structure, we split it and we have the start frame and the end frame. So that's the logic, and once the animation completes its animation cycle, it's gonna replay it in a loop. So that's the current frame. I do have enable input on the begin play with the play controller provided, so I can press the num keys and trigger this logic. So the cycle counter is kind of simple. So it starts with the 0. If I press the 1 key, it's gonna be increasing. Once it's out of the bounds of the number of animation I have from the data asset, it should reset the cycle. So it's 0. And each time I press the 1 key, I'm gonna store our current frame, which is calculated at a runtime, to be as our previous frame, so we can interpolate to each, so we can interpolate to this value. And this works as the state machine. Transition is the simple timeline with the 2 points, so it's linear graph from the 0 to 1, and that's it. So we store it as the transition alpha, and we use those values here in this mass preview function. So this one for the population, you can skip it, you just need to provide you just need to call this function at a runtime and provide those values. So on our hism component, we provide custom data value, and we should select mark render state dirty, because without this the Vertex animation won't render correctly. So the index of 0 is our current frame, the index of 1 is our previous frame, and the index of 2 is our transition alpha. And that's it. That's how it's happened. The last thing to mention is how to deal with ghosting artifact that appears on the VAT animation once you use temporal super resolution. So if I launch the game, and by default motion vectors simply won't work correctly with the VAT. If I have actually you can see this artifact already. So the higher speed is, the more this artifact will appear. And there are different kind of solutions, but I find the one more appropriate, and it's kinda easy, just to use the console command. You can use it inside the blueprint logic, but the best place I see is to overwrite the default engine config ini file inside your game directory. So that's how it looks with the fix of this issue. So navigate to your default engine config, and here, engine rendering settings, you should add this string air, TSR, shading rejection, flickering 0. With this being said, we've done with this feature, and it was a good journey. So, as always, please subscribe to my channel, leave your feedback. I do have Patreon page, so you can support me. The link is under this video. I hope you like it, and see you next time, guys.